Good evening,
Fantastic.
everyone. Welcome to this month's episode of the Melbourne Azure Security Meetup. Obviously, my name is James Westall. I'm one of the organisers this week for the meetup, and obviously this week we've got the talented Alex from Afterpay. Alex has got a history in consulting and other technical fun stuff. And he's been building out some really interesting security tooling on the GitHub platform. So without further ado, I'll pass over to Alex and he can take it away.
Thanks, James. Really appreciate it. Once again, thank you for the opportunity to speak here. It's always great, to present among your peers and discuss and learn new things. So in the interest of that, before we kick off the presentation, if you've got questions, you should be able to drop them in the comments, and James can probably stop me at the end of a slide and jump in with those questions. Happy to take them, do my best to answer them. So just to kick off, we call this one Software Security at Rocket Ship Pace. It's named after a blog post that the Afterpay engineering blog posted quite recently that I authored around how to deliver a scalable software security program leveraging automation. This presentation is based on that, but we're going to use some different tooling and techniques and have a bit of fun with it, because if I was going to do a presentation on the blog post, I'd just link the blog post. So gonna expand on it and hopefully talk some security and AppSec and security automation. A couple of quick disclaimers. So the opinions expressed in this presentation are my own opinions. They're not the view of my employer. Additionally, I will probably mention some commercial products in this presentation. I'm not personally endorsing any of these products over one another. It's actually quite important that you find what tools work best for your situation, your environment. Some of these tools may be the perfect tool for you. Some of these tools may be a terrible fit. I'd encourage you to do your own research. So, quick rundown. Who am I? Security engineer at Afterpay. James did a pretty good introduction of me. You can cyberstalk me at that link, or I've posted a QR code. I'm trying to condense a lot of information into this presentation. So throughout it, I'm going to have QR codes that you can come back to as a reference to find, resources linked, and, just a fun way to be interactive, because nothing better. Everyone's so used to scanning QR codes at the moment. I figured let's be topical and add some into the presentation. So I think the first question anyone should ask, or at least the first question you usually get when you bring up software security within the context of a business, is why is it important to have security automation? I think this goes back to where we started, right? Traditionally, when we talk about security assurance models, we define our security design principles in the requirements gathering phase and wait for the project to sort of be in a pre-release phase. We pen test the solution, and then we validate it's secure, and then we release it to prod. I'd contend that's pretty straightforward and still pretty effective in a waterfall style project delivery model. It made sense at the time and it was good. But as we've moved more towards agile software delivery with multiple smaller releases, more regular cadences, the previous model has started to fall apart a bit. It's become more expensive, and security teams started to take a risk-based approach to prioritize what they needed to test versus what they didn't need to test. With the shift towards DevOps, teams are now delivering multiple releases of production per day, and even that risk-based model, which was really, really good, has broken on us. And so the idea, the insert design requirements, then pen test at the end of the model, at the end of the delivery, has finally broken on us, and we need to leverage automation tooling in the same manner as DevOps teams so that we can keep pace with the demands of all the software engineers within our business. So now that you're sold on security automation, and if you aren't sold yet, we'll keep going and see if we can sell you. I think it's important to define, what does good look like when we talk about software security and security automation. So I think the number one thing that we should be looking for is vulnerabilities actually getting fixed. Any software security program that isn't about fixing or preventing vulnerabilities is likely going to struggle to succeed With all the budget tooling in the world, if your program fails to produce demonstrable results and reduce the operational risk for a business, it's going to fail to get buy-in from your technical stakeholders and your non-technical stakeholders. I think the next most important thing for any code security and code scanning program, especially when you're trying to establish a new program, is to focus only on blocking new vulnerabilities as opposed to holding up engineers. This approach is usually an easier sell to senior stakeholders, as they aren't asking, as you're not really asking for a massive engineering time to freeze the code base while you deploy security fixes to production and fix up all the backlog of security issues that you may or may not have in your application. So stop the bleeding, not the engineering. The third most important thing is to eradicate known bad patterns quickly. And I think this one's a bit of an emerging trend. So most security programs will periodically identify bad patterns in their applications, whether an SQL injection from a pen tester, insecure deserialization from a bug bounty hunter, or an indicator of code base compromise like we saw in SolarWinds. It's important to be able to quickly search across your code base for bad patterns and ensure it gets fixed in all of your applications rather than just one. Certainly, going back to consulting days, it was very, very often that you would do a set of pen tests and find the same bug 5 times, separated by 5 months in totally different applications from similar organizations. And so in being able to eradicate known bad patterns at scale will probably allow you to not only, improve your overall security posture, but save some cash. It's all very good and well to define what good looks like. It's easy to say, easy to stand up here and go, this is what's good. But we actually have to talk about how we get there, because knowing what's good and getting there are 2 different things. I think the first and most important thing I can say as far as software security goes is you have to build with an engineer-first mindset. Ultimately, to achieve any of our goals, we need to dig into the wants and needs of our customer. No security team goes around patching every single vulnerability by themselves in an application's code. And if you do that, I'll buy you a beer at some point when we're back in the city. The reason we don't do that is because the overhead is borderline impossible due to the ratio of engineers producing code and security engineers working to keep that code secure. As such, we need to build systems that make sense and, if possible, even appeal to software and DevOps engineers. So this is my take on what the design goals for a software security program will look like if you built it with an engineering first mindset, how an engineer thinks about their workflow, how you go about delivering products and results. These 5 things are what we identified as the best goals if you put the engineer first as your customer. No false positives. This one seems easy, but there's a bit of nuance to it. I'd contend it's better to miss findings than to destroy trust in our tooling by flooding engineers with useless noise. I'll take more false negatives if I can get less false positives. I want to have a really, 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 really positive noise to data ratio where engineers can trust the tooling and know that it's not harassing them about the same false positive they've seen 1,000 times. In the same vein, we want these findings to be actionable. If it's not possible for every engineer in your business to quickly determine what's required, they'll assume that a legitimate vulnerability or a legitimate finding is in fact noise. And so you need to have things that are actionable and clear. Those 2 are probably pretty standard. I think where it becomes engineer first is when we talk about native. So as opposed to finding the tools that the security team likes best, it's more important to find tools that fit into an engineer's existing workflow. We don't want to burden them with additional work or additional tooling to learn. We want to find the tools that are native to what your engineering team is currently using. Bring it as close to engineering team. So fast is the 4th one, and it's the feedback I get from my engineering team the most often. If an engineer needs to merge a PR in 10 minutes, they should be able to do that and be very confident that the security scans have run. I think when we first started down the software security path as an industry, we wanted to find everything and we wanted to map out every code path, and that's expensive operations. That's a very expensive operation. Now, with the shift towards DevOps, engineers won't wait a day to merge a pull request, much less they won't wait 20 minutes. And so picking the tools and the workflow that we need, it has to come down to speed. Otherwise, it'll be bypassed one way or another. The final thing that we need is flexibility. So however we design the program and the tools, we need to be able to adapt it to the needs of our engineers. So if a new framework or language becomes available, we need tooling and we need a tooling and architecture that can support that so that we can scale, we can add more tools, we can add more features. So from this point on in the presentation, we're going to talk a little bit about the building blocks and the tooling in a security program, but I'd like to contextualize this in the context of your organization. I've obviously got biases on how I view these tools and where they provide value and where they don't. That'll differ organization to organization and experience to experience. So below I've listed common terms associated with security automation. I'd contend these are the basic building blocks. So for this presentation, we're going to be focusing mostly on Sass and SCA tooling, as they're some of the easiest tools to integrate and provide some of the best coverage relative to the overhead of implementation. According to Veracode, over 70% of vulnerabilities are caused by open source libraries. There's a QR code for that reference down the bottom. In combination with a good Sass tool, it's a brilliant means for eliminating your known bad patterns from your code and preventing the bad patterns in other people's code from affecting you. And so having those two as your building blocks is a really strong starting point. Not to say that IAST and DAST aren't important, but it's a lot heavier to start there. And my recommendation would be that Sass SCA to try kill off the majority of bugs as quickly and as cheaply as you possibly can. So I've spoken a bit about the types of tools. I think it's important to understand what we're trying to achieve with these tools in a modern context. All organizations leverage open source software. It's the only feasible way to deliver products on reasonable timelines, and it has a number of security benefits over implementing everything in-house. However, not all software dependencies are of the same quality. Furthermore, perfectly good libraries can transitively include less secure libraries as part of their own dependency trees. SCA tools make it easier to understand what risk you're actually carrying across your applications. Also, at scale, it makes it easier to triage and mitigate the risk of shared vulnerable components within your ecosystem and how these shared vulnerable components may lead to a wormable compromise across your software ecosystem. There's been some previous high-profile examples of the risk of these sort of wormable vulnerabilities in shared components. Obviously, we all saw Apache struts many years ago. That's actually becoming a dated reference. I'd also contend in 2021 with the evolution of supply chain risk, this particular idea of a wormable vulnerable component is probably the most compelling and likely compromise scenario for most companies developing their own bespoke software solutions. I think finally that a new trend in SCA tools is to automatically create pull requests and update vulnerable dependencies. This trend is really taking advantage of the push towards automated software testing in the CI pipeline that DevOps teams are pushing, as by automatically creating a PR, it'll trigger off a build, which will trigger off the testing tooling already developed by the DevOps team. And so as a security team, we can start to leverage that automation to update your dependencies and then have them be validated as whether they're safe to merge or not, leveraging tooling that's been built for us. I think this trend towards automation of updating and automation of identification is going to help us scale these sorts of scale and solve this sort of problem in your software supply chain. I could certainly say from experience dealing with supply chain issues, being able to understand, the full tree of the the full tree of your software dependencies, where the risk is, what components are shared, and then have those automatically be versioned and updated is a huge benefit. Now we're going to talk about Sass. So Sass, for all the good things I will probably say about it, if you ever catch me off presentation or in real life, it's not a silver bullet. It doesn't find all issues in software. Trying to use it to find all issues in software is a dangerous path to take. It's often used in an enterprise context to identify all suspicious or vulnerable code paths. I personally found this approach to Sass tooling ends up wasting more time with people having to triage these security issues and understand if they are relevant, than actually helping your software security program mitigate the risk of code changes. Instead, I propose the problems we should be trying to solve with Sass are more along the following lines. So we want to be catching high data, low noise, low hanging fruit issues that we can identify with high confidence. It's a fantastic way to start leveraging Sass. Get it embedded in your environment and catch only the really, really obvious things. At scale as well, this has the benefit of letting you identify really basic bug classes and eliminate them entirely from your software ecosystem. This information is also helpful to understand what kind of vulnerabilities you're having consistently. If you know that the Sass tool is flagging only on these low-hanging fruit issues, and you're seeing a lot of XSS vulnerabilities, for example, then you know it's maybe a place for you to start targeting training for your engineers and for your across your organization on how to avoid XSS vulnerabilities. Another emerging trend in the Sass world is customizable rules. There's tools similar to CodeQL, which allow you to define queries to identify a particular kind of data where it travels from a source to sink flow. At scale, this makes it simple to identify if a particular issue found in one application exists in others. Simply take the finding from wherever that vulnerability was initially identified, translate that into a query, and then run that query in your Sass engine across your entire code base to work out where at scale issues are occurring. Furthermore, using customized rules in your CI check actually become a regression test against reintroduction of vulnerability classes. And so if you have a persistent issue with a particular type of XSS with a particular framework, being able to customize the query allows you to have a definitive rule catching all cases of that and allowing you to sort of block PRs that have that issue, from now well into the future, which I think is a massive, massive benefit, because reintroduction of the same vulnerabilities is a well-known pain for application security programs. I think the feature of customizable rules actually has even more use cases than just that. An obvious one is that you can leverage the results of the pen testing and improve the security of all applications via one pen test. So that's similar to as described. You could write a definition for an XSS bug found at a pen test and then see if it exists anywhere else. I think a more modern use case for this, though, is to leverage bug bounty programs in select environments and then take the findings from those bug bounty programs, which, due to the nature of bug bounty programs, are likely to do a bit more of an in-depth search due to the lack of a time horizon, and then a search for those really advanced and unlikely to be found by anything except a advanced attacker. Take those advanced attacks, translate them into a query, and then be able to remove that bad code pattern across your entire code base. I think that's going to be a really compelling way to use your Sass tooling to get more value out of your bug bounty program, which is usually an expensive but valuable program to run. Another use case that I think is quite interesting for Sass tooling that we saw relatively recently was it can actually be used to identify if your software has been compromised by internal threats that have gained access to your systems. Quite recently, Microsoft published CodeQL queries, which could be used to identify if there were any code level indicators of compromise that were similar to the victims of the SolarWinds attack and SolarWinds themselves. I've included a QR link to Microsoft's write-up, but I do think this trend of Sass tooling being leveraged in the detections pipeline alongside your application security pipeline is going to gain a bit more traction in the next 12 months, especially as we start to see these growing trends against attacks against software supply chains and systems of records. So finally, as we know, nobody today is managing all of their infrastructure by hand. Once again, this goes on the list of if you are managing a full-scale SaaS company's infrastructure by hand, I will have to buy you a beer because that is an impressive effort. All configuration is living as code these days, or at least moving towards living as code. We're calling it infrastructure as code, which is actually a really cool name. Usually I wouldn't expect it to be that good, but I like it. So this trend actually has a massive security advantage in that it allows specialized SaaS tooling to be leveraged to identify issues in our infrastructure configuration, just like how we would identify it in our code base. This new angle allows your application security team to address infrastructure configuration related security issues basically in the same triage manner as they would any other finding. I think being able to attack your infrastructure the same as your primary applications, the same as your dependencies, is a really powerful step towards automation and process streamlining the process for security engineers, and something that I'm quite excited about. So, talked a bit about the tooling, talked a bit about the design goals, talked a bit about what good looks like. How are companies actually using this information to build complicated and advanced and awesome security programs and security automation programs? So I think the thing that hasn't been mentioned yet is the push towards abstraction of tooling. You see with industry leaders like Facebook and Netflix, they're adopting the pattern that every tool in the space has a strength and weakness. This is across open source tooling and commercial. And there's no tool that'll ever be perfectly customized to your organization and meet all of your needs in one go. So being able to build a tooling to abstract out and orchestrate multiple tools, though requiring upfront investment, is becoming the trend that sort of you're seeing in leading security programs, as you can start to sub in and out different security tools in your supply chain and adjust your needs much more rapidly rather than being locked in with one vendor and building a process around the vendor. I think this investment has been shown to pay for itself quickly when you don't need to maintain configurations for 150 applications and then update 150 application configurations. Anyone who's had the experience of changing SaaS tools when the SaaS tool is exceptionally tightly coupled to your enterprise and to your code base will probably be able to speak to the true horrors that can be found there. So, one of the tools that I've seen that's come out and that I've mentioned a few times throughout this presentation that I think helps you build those abstractions, albeit within the context of a vendor, is GitHub Advanced Security. So GitHub's a pretty widely used software repository management platform. In the last 12 months, GitHub has released a software security suite that makes it easier for security teams to tackle security automation than traditional approaches. I think it really meets that requirement of having a native solution. If you're leveraging GitHub, being able to provide your security scanning and your results straight inside of that GitHub ecosystem is a real game changer and will allow your teams, within the platform to consume results in a much more meaningful way than your traditional PDF reports. So it's got a couple of functions. Real quickly, I'll run over them. It's got a Sass tool, CodeQL. We'll do a little bit of a demo of that in a second. It's got an SCA tool called Dependabot. If you're not familiar with Dependabot, go on your GitHub repo and enable it. I'll show you how to do that in a second. It's got secret scanning, which is pretty impressive, super important. We don't want secrets in our code. And I'd say by far the most awesome part of this is results aggregation for third-party tools. I'd say this is probably the biggest game changer that they are offering here. Not to deride any of the other components, but this is probably the coolest part. So as a final note, before we start to head into a demo, embedding security tooling right there inside of a platform that your engineers actually use is probably the biggest game changer I've seen in security automation in a long time. We've traditionally leveraged, what the best platform, the best scans, being able to take the platform, being able to use whatever scanning tool you like and have the platform still be what your engineers are using. I've seen has led to like a major increase in the amount of vulnerabilities we actually get fixed. And so it's a nice relationship there. So I think the most exciting part of any presentation like this is I've talked a lot about different security patterns, different approaches to software security, but I should probably actually show you that this is a thing that can be done and doesn't take, a million years to implement and only sounds good in theory. So I'm gonna jump into a demo in a second. I just want to run off a couple things really quickly. So this demo is probably a little bit different from what I'd recommend doing at real scale. The solution doesn't provide a ton of abstraction between configuration and repository. This is a major drawback. However, this demonstration is actually supposed to provide you an idea of what you could do in 25 minutes or less. I think being able to demonstrate results super quickly is a great way to lobby for the funding you need to invest in this sort of security automation. And so I wanted to create something that could be shared, could be leveraged, and could be demoed by anyone who is looking to get the investment and the funding to go build a abstraction layer for their security tooling and improve their software security ecosystem. I'd say as well the results the solution delivers, albeit on a small scale, are actually what you would look for out of your software scanning. And so if you only have one or two repos or quite a minimal amount of core apps, feel free to just directly rip this off. And if you're in a rush, GitHub's public roadmap actually has something to address the issue with abstraction here. It's issue number 98 on GitHub's roadmap, allows you to create templates for your GitHub Actions and provide abstraction to maintain them centrally. So hopefully we see that coming out of GitHub soon enough. So quickly, got a couple QR codes here. So QR code on the right, this is going to be to the repository used in this demo. I'll also try to provide James a link or maybe comment on this video after the fact for this one. So all of this is open source. You can copy it. You can steal it. Please do steal it and use it however you can. If it helps at all with security automation, then I'd be very much thrilled. The QR code on the left is also a library that can be used to automate the solution, to build the solution without leveraging any enterprise tooling. So in the solution, you're going to see I use the native GitHub Advanced Security product. There is a tool on that QR code to the left that allows you to create comments with a bot with a pull request. This would require more upfront engineering, but still allows you to leverage, the GitHub tooling and similar tooling provided here to build out, a software security POC or even, program at a smaller scale for security teams on a tight budget, which, there's a lot of us out there. Okay, enough talking. Time to jump into a demo. So for this demo, I chose to use GitHub Actions as the CI project, because if you're building your software security program totally on GitHub and you want to leverage the most native CI tooling that is baked in and pretty straightforward to use directly, you're not going to find more native than GitHub Actions within GitHub. And so we've chosen to use that as our default. I've created a fictitious GitHub organization here. So I've got a couple of repos in here, and I've got a .github repo. Now, the reason we need this .github repo is because we're going to take advantage of a feature in GitHub called GitHub Actions Organization Templates. Wow, that's a mouthful. What this feature does is it allows you to define a template for an action check that can be leveraged by other repositories with the click of a button. And so we've got this a name for our template, we've got a description for it, and we've got an icon. We'll jump into that in a second. The reason this is advantageous is it makes it easy for teams to onboard their repository to whatever sort of automation you're using. And so I've got here a empty repo that's designed to show you how easy this is. And so from the Actions menu with one click, you can immediately see workflows created by the organization, and you can directly set up these workflows. And so I've got a set of security checks here that I would like to be run. And with one click, we can basically have all of those security checks pulled into this repo and ready to run. I think from an onboarding point of view, anyone who's onboarded to sort of more traditional products or more traditional more traditional CI products, you've probably found that it's a bit of a process to get everyone onboarded and hooked up and configured with your software security tooling. I think being able to leverage these organizational workflows and have that one-click flow natively integrated makes it possible for teams to onboard themselves rather than the security team having to go perform onboarding. So I'm going to do a quick run through of what this scan does. Then we're going to do a run through of the results and a couple demos of the scan running. So in this scan, I've got a couple of checks I'm going to run. So I'm using a tool called KICS. I believe it's developed by Checkmarks. It allows you to define rules for infrastructure as code security across CloudFormation, Terraform, Kubernetes, probably a whole bunch of other stuff I'm forgetting. And it allows you to define those rules for that as Rego, which is being heavily leveraged in the Kubernetes landscape with things like OPA. Sorry, not OPA. It's got a new name, Gatekeeper. And so you're basically using a well-established language for those of you on Kubernetes for your security products that can go in your CI check the same way that it can go as your validation webhook. So this is we're going to use this to scan our infrastructure. We're going to run the aforementioned CodeQL to scan our actual code. We're going to leverage the native security checks in there, and we're going to use the JavaScript language. This can be configured to any language. We're going to also leverage another Sass tool, this one entirely open source, called SemGrep. It also allows you to define rules. It's just another tool you can use if you'd like to play around with some tools to catch other patterns. And so that's it. We got 3 checks in here, plus the Dependabot checks that we'll jump into in a second. It's all defined here as YAML. This repo, once again, open source, so you can copy paste this YAML file and achieve the exact same results as shown here. Let's hop into a repo where we've actually got this activated and we've done some scans. So right off the bat, with this repo, we've got something standard. We've got our app and we've got our Terraform configuration or our infrastructure as code. So the thing that sticks out to me as a security person is that security tab with the big 135. So the nice thing about GitHub Advanced Security is it's pushing the alerts directly into the GitHub UI. And in fact, if we come here into code scanning alerts, we can see all the results across all of our tools being explained, contextualized within the code. So if we take a look here, I've opened up a finding. It's got the line of code, highlighting the code, information about what's going wrong here, a bit more of a description of the problem, a real full explanation, something that I can do something with. So I can see here that there's a credential in plain text, and maybe I need to not store this credential in plain text, or maybe it's fine, easy enough to triage. We can take some more complicated things as well. So here's an example of a code execution vulnerability. And so we can see here it's flagged this particular line of code for a code execution, probably because we're seeing an insecure deserialization. But the problem with a lot of these vulnerabilities is it's sometimes hard to work out where that came from. And so the CodeQL tool actually provides you a full path for the data flow. So you can quite quickly validate where did this data come from and how did it end up here. Tools can also inject more complicated recommendations and examples. It's pretty standard markdown, but a lot of the native tools and the tools that are well integrated with this will actually give you sample code to understand what the problem is and how best to go about fixing it. Additionally, there's metadata you can collect on CWEs and sometimes OWASP top 10 categories. So obviously, it's all very good and well to have the security tab here and be able to do some easy triage with the code right there within the GitHub repo, possible for security teams to perform that triage, possible for engineers to perform that triage, possible to go through different types of tools and different types of scans you may have running. But the biggest question for me is, how can I stop the bleeding? Because I'm not going to be able to fix these 113 issues before I get back to work. I'll need to work on that over time. But I don't want this 131 to become 231. And so I've got here an example of a fictitious pull request with some bad code changes. It's well documented. This PR adds some issues to demonstrate the power of security automation. So we're about to feel the power. And so if we take a look here, if we go to the files changed, this check actually lints your PR to show exactly what's gone wrong and lets you click into the full finding for information. This integrates quite strongly with how most engineering teams will perform code review within GitHub, where you'll read the code, you'll take a look at the files changed, try and understand what's going on, and being able to immediately see that this check has failed for this reason is quite a potent way for engineers to hold each other accountable and understand what's going on and to do some triage with each other or to reach out to the security team. So it's cool that I've got this all prepped, but if I don't actually run the CI tool live, there's no way to believe that this isn't, all forged. And so what we're going to do is we're going to hop in and we're going to inject the most contrived vulnerability I can think of in a second. And so the most contrived thing I could think of is, let's get a JavaScript file. Ooh, typing's difficult. I'm going to say let x equal, 1 plus 1. So maybe not quite a vulnerability, but certainly something you don't want to see too often in your JavaScript code base, likely to become a vulnerability. No one's a huge fan of using eval. And so if I commit this, and I better make sure I'm on the branch, if I commit this directly, we're going to trigger off our CI checks. So let's go to the pull request open for this. You can see I've just pushed a commit. And we've got some checks running here. So we can go take a look into these checks. Setting up the job, getting ready to do the scans. This may take a second. So James, if you've got some questions, now may not be a bad time. Yeah, it's probably I can't.
So the only question we had was around the cost for GitHub Advanced security features. Obviously, that's an add-on for enterprise security. And we've had, I believe, Andre in the chat give us some guidance there around, from an enterprise perspective, it's an add-on, and then for free public repos, it's free for public repos. But aside from that, I didn't think there was any other costs you had with your whole solution. Is that correct?
No other cuffs with the solution. And actually on that demo slide, I'll go back to it for a second. If you take the link on the left, there is actually a way to do this without GitHub Advanced Security. If you want to invest some more engineering time, it's a slightly different solution. It's not quite as natively integrated, but you can create a comment bot with an OAuth plugin using that JavaScript library that's there. So basically the way this works is it outputs a Sarah file. With a Sarah file, you can sort of read what the vulnerabilities are and do the diff yourself. It's more engineering work, so you got to assess if that trade-off's right for your organization. For the sake of the demo, right? Because it's an open source repository, and we want to help open source leverage as much security tooling as possible, as fast as possible. I've used the freemium, if you will, product, but it's totally possible to get similar results in a fully free environment, albeit CI costs and the time of integration need to be accounted for. But the standards used behind the scenes on this are somewhat portable, and so you can use you can get similar results for free. So we've run our check and we're getting some failures, which is good news because if I added a vulnerability and we didn't get failures, that would be not very impressive. Oh no, but the main branch has come out of sync. Oh, live demos. The dream. Okay. 30 second quick fix. We need to get a latest scan for the default branch. What happens when you test something prior and then break it? No other questions to cover up for my live demo fail?
No, I thought you sacrificed the goat. You told me you did.
I did. I worked as hard as I could, man. I
Right.
prayed. I did what I could, but get you every time.
Happens to everyone.
Oh, we will have to wait for the CI to run through again a second time, and this could take a minute. If we don't have any more questions on this,
I do have one.
We consider silence.
No, I do have one for you. I suppose you talk through identifying vulnerabilities using the solution, right? And obviously stopping that bleeding, and then ensuring that it doesn't, or something doesn't appear in your your environment again. Did you go through a process of saying, well, I'm going to focus on this area first, or was it all based on what was coming out of your scanning around CVSS, right? If you were you focusing on saying, well, I'm going to secure my infrastructure layer first and focus on stupid things like public S3 buckets that everyone seems to create, or was it more around let's just take a holistic look at all the code and then prioritize based on that?
Yeah, it's a great question. It's a pertinent one as well. I think also for anyone who came to the previous session, it'll probably give you an indication of how I believe you approach that sort of issue. But we tried to do some threat modeling to identify what were the likely scenarios of compromise based on our internal engineering and application security understanding of our product and our ecosystem. We really wanted to identify how is it likely that we get compromised? What are the things that really stand out to us as a way we see ourselves getting hacked, or ways we specifically don't want to see ourselves get hacked if there was if there were better ways to go or worse. And so we went from there and then started to identify what classes of bugs we could wipe out within that and what classes of bugs we couldn't wipe out. And so the classes of bugs we then sort of built rules on top of, and measured our effectiveness against. And if we started to see them appear in prod or be found by pen tests or bug bounty hunters, that's when we can start raising alarm bells and go back to the drawing board. And so we're trying to turn the continuous development cycle into a continuous security feedback cycle, if you will.
Yes, it's all about shortening that that cycle, that loop between your development and engineering effort, and then what's coming out of your tooling. Is correct?
Yeah, precisely.
Yeah, I think we've finished our checks.
Yep. Yeah, I'll have to rerun this one. So we got about another minute in here.
Cool. I suppose the other question I had for you was it a steep learning curve to pick up things like actions? Obviously, as a newer one of the newer kids on the blocks in terms of CI/CD, or how did that work for your AppSec team to actually pick up tooling like this? Was it challenging or not so much?
So we actually, in our solution, leveraged our own CI. So we had a separate CI set up, and we built the tooling on top of our own CI because that made sense in our context. I think the reason I'm using actions for this demo is because it's quite easy to get set up with. And so if you don't have access to a CI or a unified CI strategy, being able to deploy something in actions is kind of an easy way to get results fast. And sometimes results fast lets you get that momentum you need to really develop your program and go from getting results fast to getting cutting edge results. But in terms of, sorry, I dodged your question like a master there. In terms of the difficulty, because I did actually have to work with Actions to learn how to do this, didn't find it very hard to leverage Actions for this. It's pretty similar to other CI tools, right? Like as opposed to writing Groovy, you're writing YAML, but it's reasonably straightforward. You can use, like I would recommend with any tool. I took configurations from other people, I tweaked it, modified it, put it together. Didn't work. Tested it again, then it did work.
Nothing a good old Google couldn't fix.
Yeah, no, that's true. That's true in all cases.
Yeah.
Now there's nothing Google can't fix. Well, I think we need to create a new branch here because I've desynced it. So, not my best demo ever.
That's all right. It happens to everyone. While we do that, I suppose, was the integration with external CI challenging or not so much?
I think it was a challenge, right? You have to understand how your organization is leveraging CI. We had to find a way to integrate with it. We had to find a way to make it fast with our integration as well. You can't have your integration lagging behind the other CI tools. One of the main learning points that we found was that if our CI was, if our security scans were slower than the standard testing process for an application, people would just ignore it or try to get admin privileges to get around it or just do all sorts of non-desirable behaviors. And so I think the journey, the most difficult thing was understanding how CI was used in our environment, and then from there taking what we learned and understanding how we could integrate a tool that's abstracted enough and still fast enough to provide the value and the results we were looking for. Long-winded way of saying learning the environment was so much harder than actually combining tools and more important.
And that's obviously related back to that whole, you can have visibility of an environment, and from a security perspective, that's really important. But obviously, understanding it and learning it and having that context is, generally speaking, a little bit more important than just being able to see it. So we are still running an action.
I feel good about this one. I really do feel like this one's the one. Otherwise, we'll retire to the next part of it, and we can call this a test fail. So we'll see if these ones run. No new alerts. So expecting one of these to flag that eval, and if they don't, I guess I will have to hang my head in shame.
We've got one pass. That's positive.
So it should pass, but it should have a little bit more data. We'll see how we go.
Now, did you have to write a lot of semgrep rules, etc., yourself as a team, or was there decent resources you could find for that online?
So initially, we just leveraged the standard tools. The nice thing with a tool like semgrep, going off script on the demo since the demo is going so well, is there's actually a testing environment. So this is another one of those open source but with a commercial offering style tools. I think it's Open Playground. We can actually use this environment to sort of test out our rules and see how they work. So, if we wanted to find an example of like an old print function that read like old print and took a variable, we could test that there. You can combine these rules and sort of build them. Combine these rules and build them to get the results you're looking for. And so if we run this, it's brave to go off script and then take a rule that you've never read before and then modify it. You can see this reference of old print is being picked up. We can also add, see, we've got this old print function and then it's getting imported as old p. We can also should in theory get detected. I did. New old print is a bit of an oxymoron, isn't it? There we go. And so you can sort of validate rules that way, to get a snippet of your code, test against that, start to combine them. And so we basically started with a default rule set, worked out what was going well for us, what wasn't, and then built our own rules on top of this based on how our code base is designed. Let's see how we went with that CI check. Maybe it's smart enough to realize there's just no vulnerabilities in this code. Let's give it something really vulnerable. I think I'll move on to something else though. I've embarrassed myself enough. One last check. We're going to write some Python 2. Oh, James, would you believe me if I told you that I tested this not even 5 minutes before and worked absolutely fine?
Without a shadow of a doubt, my friend, I've done the exact same thing for Microsoft presentations and had the demo work at 1:30 and fail at 2:30 when it's live. It's just how these things work, unfortunately.
The good thing we can talk about is SCA. So SCA tool inside of GitHub Advanced Security is Dependabot. It has a couple of cool functionalities. It can identify things that are vulnerable for you. And so here's a vulnerable bcrypt dependency. We can also use it to create a security update. And so automatically we can have a pull request opened for this. Might take a second. If this fails, though, I'm blaming GitHub. This one's not my fault. There we go. Okay, so it's generating a security update now for this particular problem. And so you can go through, understand your dependencies, generate fixes for them automatically, and maybe it'll work. Fingers crossed. How did we go here when we switched languages to Python? Just got a bad feeling about this one. You got one more question for me, James, just in case, to fill the time as we wait for more CI checks to not do what they're supposed to.
We do. It's a meaty one though, so I want to give you a bit of chance to actually respond to that. So this is probably only have 30 seconds left with it, right?
Redemption.
There we go.
Redemption.
Look at that.
Worked as expected. So I guess it was just such a smart software security system that it knew there was no real vulnerability in that because I wasn't taking user input. But thankfully, now that I'm taking user input in a responsible way using Python 2, it's caught on to that and it's told me that I'm in trouble, which is exactly what we want to see, right? It's calling out the problem, it's directly in line with the code, and it's prevented a vulnerable change on the PR. And I guess you could take as a positive of my failed demo, it didn't flag on code that actually wasn't vulnerable, which is pretty good. Maybe there was a change in the rule set in the last hour that's messed me up here, but that's awesome that the default rules didn't flag on something that was a fictitious vuln, but when something that was actually vulnerable came around, it did flag.
And that loops back to what you were talking about earlier around you'd rather have more, you'd rather miss stuff than put the wrong vulnerability in front of your users, right?
Yeah. Would it be too much to play it off as if this was the intended point of the demo the whole time?
Oh, you're a pro, mate.
No, fabulous. Okay, I'm going to flip back to the presentation. I want to provide just another second to scan those QR codes. So once again, QR code on the left is some tooling to do that in a bit of a free manner. QR code on the right is the actual repository. Otherwise, I will try and dig up this video and comment that on it if you want to play with this in your own open source libraries and have your own live demos go astray. More than welcome to. I'd encourage it. Okay, and I guess the final part is any questions. And just quickly, that last QR code, that's a link to the original blog post. That's a more in-depth description of Afterpay's implementation of a code security program. This presentation is designed to be a little bit more generic, but we'll dives into how the Afterpay security team went about solving this problem in our environment and what our learnings were. So if you're more of a visual person who likes to read stuff rather than listen to my voice, I would highly encourage you to give that a read.
Beautiful. So I suppose the final question we've got, and this is really not so technical, it's more around your culture and your process. How did you find the key challenges when building a DevSecOps culture within the community, the developer community, and what are some of the strategies and techniques you took to overcome that? Because it can be a big change for a lot of people, right? Moving to security so early in the code base.
So it's a really great question. It's a meaty question. So I'm going to try and dig into it as best I can. So I think there's a lot of things. It's less what we did and more what we didn't do. And so some of the things we didn't do is we didn't force the process on anyone initially. We didn't mandate you must have security checks. We sort of came in as a startup security team and built it out. And so we started building the tooling with with an engineering team that was passionate to test this kind of thing and wanted to try it. And we really built it with them as our customer and got them to provide us feedback all throughout about, did the tool actually help them develop faster? Did it meet their use cases? Was it actually providing helpful feedback? And so we really just took one engineering team to start with as opposed to the entire organization and worked as closely with them as possible to understand their needs and then build a solution that met them. And I think that's where some of the things that we didn't expect really came out. Like the first demo that we ever tried of a code scanning tool, the first issue that was raised within about 5 seconds was speed, because the code scanner took 30 minutes, which we thought was pretty good, right? Because a lot of code scanners can take, days. And they were distraught at the idea of waiting 30 minutes to merge a pull request, which was valuable feedback that we didn't really think about prior. And so just talking about how we started, we actually started by understanding our customer better. There's no better product manager than the people actually using it, and we're very fortunate that we had some understanding engineering teams who helped us. From there, actually building it into a culture, it was one part marketing and one part leveraging existing process. And so the marketing component was we actually went to them and said, this is a bit of a trial. You can onboard yourself. We're not going to force you to onboard, but here's the steps to onboard. It's 1 or 2 clicks, and we'd love to hear your feedback about how we can build this and make it better. And so as opposed to sort of having a security be something we did to people in the organization and did to engineering teams, we asked them to come to us and work with us on the tool before we scaled any real rollout. And so we got to about 30-40% capacity in 3 months just by asking people to onboard themselves. And going in with with a sort of offering hand to work together as partners rather than to work against them. And we basically said, if there's issues with the security checks, let us know. We'll prioritize that as our first point of call. We're not going to block your engineering program. And we really dedicated time to that and understanding how our solution worked, what were the deficiencies. I think the second part, which was admittedly a tiny bit lucky, was we were able to leverage the way engineers actually work in our organization. And so when we talk about people creating, performing code reviews, at least in my experience as a former engineer, there was nothing I liked better than calling out a bug in my buddy's code. If I could find some issue with his code or her code, it would be the best day of my life. That was me personally. That doesn't speak for all engineers, but so some engineers just do it because they're serious and trying to produce high quality software. And so having these checks be so in line with the process and right there visible to see for anyone doing a code review really helped with engineers keeping each other accountable. And by accountable, I don't mean engineers didn't care. I mean actually making sure that the triage is done right, understanding what's going on, chatting about the issue, and then raising it to the security team when relevant, or just fixing it if that was fine. I think that was probably one of the most major things for us, right, is just having it that native, that clear, and not having to send a PDF in an email that no one opens. Because that was once a design proposal that we thought about, and then we realized no one likes to read email.
Who reads PDFs in 2021, right?
Exactly. So hopefully I've unpacked that question enough for you there. But it is a tough one, and honestly, you could almost do a whole presentation on how to build a security culture and a DevSecOps culture. It's not easy, and there's probably a component of luck in any of it, right? There's understand your users and hope for the best.
Yeah, culture is definitely something that can be, for a lot of people, really, really difficult to manage and change over time. So, that you can push stuff into a developer's face without actually being the team that says no or doesn't engage well is really positive, and it's a decent way for you to obviously transform user behavior.
Yeah, like anything, you build the groundwork, right? As a security team, your actions tell the people in the business how you're going to behave. If you can build that trust, which takes time by working with people and partnering, I think that'll probably put you in a lot better position to launch something like this than sort of being the security team that always says no, or the no fun police.
Very much the case. One more question that's just come in is, how did you reduce false positives noise from the tooling? Was this used as criteria during proof of concept for tool selection? Is CodeQL one of the best in industry when it comes to false positives?
That's a really good question. So, as far as that was actually one of our top criteria, I think it was our number one criteria was low false positive rate. It was very important to us during the POC, right? A lot of times you do a POC for a Sass tool, and I've been guilty of this in the past, so I'm definitely not preaching. But you'll pick the tool that has the most findings because that's the best tool. This time going in to do a POC, it was actually the tool that had the most had the most accurate findings. Now, in terms of how we evaluated that, we basically went through, we did a scan on a subsection of our repos that we thought were indicative of the trends in our code base. And then we manually triaged and went, okay, how many, what's the percentage, what's the false positive rate, right? And we wanted to understand what tooling was providing us the lowest false positive rates. The caveat here is a lot of modern tooling is tunable, and so you can configure these rules and change them yourself. In our use case, we found CodeQL and SemGrep to work quite well as complementary tools. We found the base rule sets worked quite well for us. That may not be true for every organization. It also could be true, but you'd have to test and validate that yourself to make sure that you're getting a good noise to data ratio that makes sense in the context of your organization. Additionally, we thought about what we wanted the tools to do. So for us, CodeQL we viewed as this heavy data flow analysis engine for us to make assertions in our code base about, does data travel from this source to this sink without hitting this function, and being able to do that at scale. And so we also contextualized that against what rules were provided by default and what rules we could just rip out in a second. But yeah, we obviously in our evaluation, we ended up using it, so it did pretty well. And then we viewed SemGrep actually as this lightweight scanner that can pick up some code patterns, but also is really cheap and easy to use to find bad config and write new rules for. It was more false positive heavy, admittedly, initially, but the rules are basically just like fancy version of grep. They're very easy to write, and so we basically just stripped out most of the default rules and started writing our own, and it was unbelievable for that use case of just like, here's the known bad patterns, let's press one button and find them across our code base. Or even things like hey, we know does this application use the standard library for doing something, or does it use the internally developed and maintained library that has all the security defaults enabled? We found that really good for that. So I'd say it was an evaluation criteria. It did turn out well for us, but you got to evaluate it in your own environment and see how it works for you.
Makes absolutely perfect sense. I suppose final question before we kick on to just some things for later in the year. From John, he's wanting to know, could you please show us where you modify and configure the rules? How easy is it?
Yep. So I can bring up an example for this demo. I haven't done it specifically for. So did you want John? Did you want to see SemGrep, CodeQL, or both?
Just give us a sec. It'll pop up in chat, I'm sure. I suppose one would be easier than the other, I'm guessing.
It's just different more than anything else. It's definitely not very complicated. SemGrep, I can do SemGrep quickly because it's quite straightforward. You have this rules file that you put together. It's just a YAML file. And so what you do is you can copy that, paste that into a text file, and you just concatenate all the rules together. And you just run it like semgrep -f for config, file name, and then the directory you want to scan, and your output format. So like it's pretty easy in the semgrep use case. That's not good. It's also pretty easy in the CodeQL use case, albeit slightly different. I'm just trying to think if I can dig up, without going to anything internal, a CodeQL config example. If Andre's in the chat and he'd like to show an example of this, that would be very helpful to dig up one without having it here. Oh, here we go. This is it. The documentation. Documentation once again for the win.
When in doubt, Google it out. I love it.
It hasn't quite got us there. That's okay. We can problem solve this live. It's basically you need two sets of config files. So you have a config file specifying the scan directories, and then a second directory that basically specifies the checks, and you write them out in that query language. If I could find them, it would be very, very helpful. But
it might be worthwhile putting them in the comments for the meetup group, and then John, we can probably link you up offline if you really want to have a detailed conversation.
There we go. Here's what it looks like. It's basically a config file that looks like that. And so you can say, use this location and start to go wild with your checks. And it's actually an open source repository, CodeQL checks. So if we go, the checks, I believe, are all open source. So you can see the queries here. You can use them to write your own. Oh, here we go. Security, different CWEs. And we can see the query here.
Right. So this is using GitHub Actions. The example you pulled up in the docs was using a pre-built action, right?
Yeah, you can use it in custom CI as well. You just need to fill out the proper config file and then specify it from the CLI.
Yep.
There's a GitHub Advanced Security, CodeQL in your own CI GitHub documentation page that is exceedingly helpful if you want to configure that.
Yeah, nice. All right. I believe that's all the questions we've got for now.
Awesome. Can I say a huge thank you to yourself, James? Obviously, the Azure Security meetup, wider the community has come, and everyone's time for listening to me. Hopefully, provided some value. You learned something. You got something you could use, and if you didn't, I suppose be nice to me online.
Yes. So, Andre, if you want to flick us a link, we can post that straight onto the meetup page. Andre's also provided some nice documentation from GitHub. And yeah, Alex, a huge thank you to yourself. The community group as a whole wouldn't be where it's at without people like yourself volunteering. The standard, spiel that I give every month. If you want to present, reach out. You can reach out directly to me on LinkedIn. James Westall, you'd be pretty quick to find it, or you can reach out on the meetup page. I'll definitely respond faster if it's on LinkedIn and you're interested. As far as events go, we have a new event scheduled for July 21, and we've got Michael Birchall, who's a cybersecurity guru for Reese Group, and they've recently deployed Azure Sentinel, so he's going to come through and talk about some of the challenges that are involved in deploying Azure Sentinel, what that looks like, the retention, and all of the nitty-gritty that goes with Azure Sentinel. And we're really looking forward to having him through. We do have a speaker lined up for August as well, and that will be announced shortly. So there's more than 8 weeks to get on board for that one. And then later in the year, looking to get some feedback from the group. If people want to send messages or write comments, we're looking to run a CTF on Azure. We're still trying to work out what that looks like, whether that's your standard red-blue CTF, or we just focus on actually hacking out some neat Azure solutions in person, hopefully with some COVID restrictions lifted. But until next time, a big thank you to everyone who tuned in, and looking forward to seeing you all at the next month's meetup. And if there's any updates about in person, then I'll let you know via the page. Until next time, everyone, stay cloudy and have a good night.